This video is about creating arrays, and the thing you want to note is that pretty much anything you did in vectors you can do in arrays. So going over to MATLAB, we're going to step through some examples here. So here on line 10 we create an array called A1. Now the way you do an array, and I'm going to note arrays with capital variable names instead of lowercase. That's just a way for us to delineate. It really doesn't matter except for by convention here. What you do is you'll have your elements in the array. So in this case I've got 2, 5, 7, and you notice I put the semicolon. The semicolon tells us to go to another row. So what we're creating is not just data in columns, but also data in rows. And so in this particular example we have 2, 5, 9, 45, 99, 77, semicolon, 1, 3, 4, 2. And what that is that gives us an array that looks like this: 2, 5, 7. That's the first row. Semicolon, next row, 45, 99, 77. Then you have a semicolon, which gives you the next row: 1, 3, 4, 2. Now, you noticed each one of these rows has 3 things in it. That's a must. Each row must have the same number of elements in it. And then you can have as many rows. This one happens to be 3 by 3. I could have done one 2 by 3, 4 by 2, 6 by 8. It doesn't matter, but each row has to have the same number of elements in it. And we'll see that more as we go through examples. So the semicolon is one method used to separate rows. If you look here over in MATLAB, the second way to do it is you can actually open up brackets and then put each row on a successive row. So here we have A2. We open the bracket here. We put in 2, 5, 7. Hit the return key, hit the enter key, and start a new row. And MATLAB understands that your intent was to create an array. And so you start another row here, 1, 3, and 42. And then you close the brackets, and that tells MATLAB to stop, and that's what you need for your vector. Excuse me, for your array. Now, once again, you have to have the same number of elements in each row, but you can separate it. So open bracket here, close bracket here, and then you can do a return. Oops, you do a return each time here, and that takes you down to the next row. And so these are the 2 different ways that you can do a direct entry on 2 different ways you can do a direct entry on arrays. So I illustrate that here in A1 and A2 MATLAB. You see both of these methods, A1 and A2, generate the same equivalent array. Another way to do it, of course, is with your range. So instead of actually explicitly saying the elements that you want here in your rows, you can use a range to do the elements you want. So 1:4, 2:5, 3:6. In other words, these are just vectors separated by semicolons, and that's going to give us the array 1, 2, 3, 4 in the first row, 2, 3, 4, 5 in the second row, and 3, 4, 5, 6 in the third row. Once again, the rows are separated by these semicolons. Likewise, you could do a vector B2 and do the different line method instead of the semicolon method. So it doesn't really matter which one you use. This one tends to be B1. This method tends to be a little more streamlined than the method we used in B2 and A2. You can also do it with linspace. So basically what we're saying here is anything that would generate a vector, it is an array is just multidimensional vectors. And so in C1 we use linspace to generate the first row, 0, 10, 6. Start at 0, end at 10, have 6 elements in there. Then we use this linspace to generate the second row, this one to the third, and this one to the fourth. So this is a 4 by 6 array. And I do the same thing here using the different line method in C2. So you can see that. Okay. You can also mix this, as I do here in vector E. You can do This one I use the direct entry method for the first row, the range method for the second row, and the linspace method for the third row. And so that generates a mix, that generates an array that looks like this. Either way, depending on what you're using, is preferable depending on your situation, but these are the ways that you actually create arrays. So next up, I like to look at how do you do zeros and ones. Once again, these are the same functions that we used when we started vectors in our introduction to vectors. So let's talk about, there are a couple of ways to do a zero vector. On line 36, I say 0 is 3, so it's going to give me, as you can see down here, a 3 by 3 array of zeros. On line 37, I say 0 is 2, 5. Keep in mind, it's always rows, then columns. Always rows, then columns. So this is 2 rows, 5 columns. 2 rows, 5 columns of zeros. And you can see down here, Z2 has 2 rows of zeros and 5 columns of zeros. On line 38, I have array 0, 1. So you use the ones function. With just one number in there, it's going to give me a 2 by 2 square array of ones. On line 39, I say 5 rows, 3 columns. Rows, then columns, rows, then columns. So this has 5 rows, 1, 2, 3, 4, 5, and 3 columns of ones. This actually comes in very handy when you do some operations in the future. And then you can do random. Keep in mind, random is going to do a random numbers between 0 and 1, non-inclusive. And so when we go random, let me just summarize here. Zeros, always rows, then columns. If you give it one value, then it will be square. So, spell zeros. Zeros. If I give it one single value, n, then it will be an n by n. Okay? Same thing with ones. Always rows, then columns. And then if I give it a single value, n, then it's going to give me an n by n. And then the same thing with random. Always rows, then columns. And then if I give random a single value n, it's going to give me an n by n. Keep in mind with random, the values that random are going to give are going to be between, their values are going to be between 0 and 1, not equal to 0 and 1. So it's not inclusive. So when I do R1 here on line 40, these are random values between 0 and 1. And it's a 3 by 3 because we gave it a single value. On line 41, I do a 4 by 3, 1, 2, 3, 4 rows, 3 columns. And once again, these are random values between 0 and 1. Now, if I wanted to create, and this is an example of how to create random integers between 10 and 20. So what I do is I took R2, took all these values, multiplied them by 10, which now move the decimal point over to the right one in each one. So now these were values between 0 and 10. And then I added 20. I'm sorry, these are going to be random values between 20 and 30. And so what I did was I multiplied R2 times 10, which moved the decimal point over 1. So that got me values between 0 and 10. And then I added 20 to them, and then that got me values between 20 and 30. And then I rounded them, used the round function here. And what round did, and I could have used ceiling or floor, but I used round here. Using the round function, what that did was round it off and got rid of the decimal point. So if I go and look at R3 here, this is it's R2 modified and get the rounding. Now, the thing is, you're probably looking at this and you're saying, well, wait a minute. Well, no, that's right. If you look at this and you say 9.8 rounded will give you 10, and then 10 plus 20 will give you 30, and so that's what this is here. So you can go through and look and convince yourself that this function on line 42 actually generated these values in R3. Okay. Next up, you have two functions one called diagonal, one called magic. The diagonal function, you give it a vector of values, and it puts those vector of values on the diagonal. So just as an example, D1, the function is diag, diag. I give it a vector 6, 7, 8, and it's going to create a vector, an array with 6, 7, 8 on the diagonal, and everything else is filled in with zeros. So my diagonal is going to be 6, 7, 8. So of course, the longer the diagonal I give it, whatever the length of my diagonal, or this vector, what I put in here, the resulting array is going to be an n by n. And so that's what diagonal does. And so you can give how you create the vector inside the diagonal is up to you. So in D1 here, as I just illustrated, I put 6, 7, 8 on the diagonal. In D2, I'm going to use the range operator, 2, 3, 12. That's going to give me 2, 5, 8, and 11 on the diagonal, so it creates a 4 by 4. Linspace, 1 to 34, 4, so I'm going to get 4 values on the diagonal, so I get a 4 by 4. And then if I give it a one-dimensional random vector, it's going to use those random values and put those on the diagonal. So diagonal controls the values that you put on diagonal, which when you start doing a lot of matrix operations, that's very helpful to control. Next up is magic, and this one's sort of interesting. What magic does is it creates an array where if you sum up, and so this one is 8, 1, 6, 3, 5, 7, 4, 9, 2. If you sum up all the rows, they will equal the same thing. In this case, 15. If you sum up the columns, they all equal the same number, 15. And if you sum up the diagonals, both this one and this one, they all equal the same number as well, 15. And so the value you give magic, so if I give magic value of 3, it does a 3 by 3. If you give it a 4, it does a 4 by 4, as it does here with M2. And if you give it a 5, it does a 5 by 5, and so on and so forth. It does not work for 2, though. The value of 2 doesn't come out quite right. But if you do this, and if you want to do the math to prove to yourself that all these rows, columns, and diagonals are all equal to the same value in M1, and then in 2, they're equal to the same value, and in 3, they're equal to the same value. So this is a brief introduction on how to create arrays, much like when we created vectors.